want to take a look at an example here where the limit as you go to infinity is actually different than the limit as you go to minus infinity. So this function will have two different horizontal asymptotes. Okay, so here we go. It involves this radical. I'm going to actually I'm going to do this a couple different ways. Personally, I look at this and say, let's start first of all with the limit as x goes to infinity. Let's say what we're actually doing here. The limit as x goes to infinity of this thing, the square root of 4x squared plus 5x plus 2 divided by 7x minus 9. So as x is getting really big, I'm looking at this denominator here and saying 7 times really big minus 9. Very quickly that minus 9 will become irrelevant. Okay. Likewise up here, the 2 will become irrelevant. The 5x will become irrelevant. The only thing that really matters here is the 4x squared. Well, but it's the square root of 4x squared. So I've got a square root of 4x squared on the top, and I've got a 7 on the bottom. Right? Sorry, 7x on the bottom. As x gets bigger and bigger and bigger, these are really the only things that matter. Well, here's where I got to be a little careful in that the square root of 4x squared, I want to just say 2x, but it's really 2 times the absolute value of x, because I don't know whether x is positive or negative to start with. Right? And this is how I end up with two different limits. When x is going to infinity, right? When x is, oh, wait. Okay. X is going to infinity, I do know x is positive, right? I do know x is positive, so this absolute value sign really doesn't do anything. This is just, that was supposed to be an equal sign. This is just 2x over 7x, and so the answer here is 2/7. Right? The x's cancel out. If x is headed to minus infinity, the limit as x goes to negative infinity of the same function, I'm still thinking of this as 2 times the absolute value of x over 7x. That is, again, I just, when x is headed to minus infinity, the small terms don't matter. It's only the biggest power on the top, it's the biggest power on the bottom that really matters. And so, and I'm still worried here in that when I take a square root of an x squared, I don't necessarily get x back, right? If x is positive, yes, I get it back. If x was negative to start with, you square it and then take the square root. That's not going to get back to where you started from. In particular here, I'm headed towards negative infinity, so x is negative. So the absolute value of x is actually negative x, right? Remember, x is negative, so negative x will be positive. It always looks funny to me to say, oh, that this is negative. Well, it's the opposite sign of whatever x is, right? If x is negative, then the absolute value is going to make that positive. Well, that's what that negative sign is going to do as well. So here, the x's cancel out, and I get negative 2/7. Right? So it looks to me like there's going to be a limit of 2/7 as x goes to positive infinity. There's going to be negative 2/7 as x goes to negative infinity. I'm going to look at the graph at the end of this video, but what I want to do first is I want to show you how the book would do it. I'm very happy with people being able to say, hey, I understand that it's the biggest term that's driving stuff here when x is headed towards infinity. If x is going anywhere else, then we're going to have to do different things. But as x is going to infinity, when x is really big, x squared is so much bigger than x that you don't really have to worry about the x. And that's so much bigger than 2 that you don't have to worry about the 2. Okay. However, I'll justify it to you and show you what the book's doing. I'm going to do the top one, well, either one again. Let's take a look at that again. I'm taking the limit as x goes to infinity of the square root of 4x squared plus 5x plus 2 over 7x minus 9. The way the book does this is they look at the biggest power in the bottom and they say, I want to multiply by 1 in the form of 1 over whatever that thing is. So I got an x. I'm going to do 1 over x on the top, 1 over x on the bottom. So this is the limit as x goes to infinity of, distribute this in here. So this is 7 minus 9 over x. Now in the numerator, actually I got to Slide this down a little bit here. In the numerator, what I have to do is I got to first of all get that underneath the square root. And let me remind you of stuff we do, you've done for a long time. If you had something like, what's the square root of 50? You want to simplify that radical. At least that's the way we talk about it. Simplify the radical. You think of this as 25 times 2, and the 25 can come out of the radical as a 5, right? Well, if you went backwards and you started here, you could bring the 5 in as a 25. That is, as you take it out of the radical, it gets its square root taken. When you go into the radical, you have to square it. And that's what I'm going to do here. I'm going to slide this 1 over x inside that radical, and it's going to go in as a 1 over x squared. Right? So it's going to go in like this. On the outside of the radical, it was a 1 over x. On the inside, it's a 1 over x squared. And now I can distribute that in. So I've got the limit as x goes to infinity of 4 plus 5 over x plus 2 over x squared. That's all under the radical, and the whole thing is over 7 minus 9x. Okay. Now, as x is headed towards infinity, let me grab another color here. This is headed towards 0. This is headed towards 0. This is headed towards 0 because you got a constant divided by some big number. That's going to be small. And what are we left with? Well, we're left with a square root of 4 on the top and a 7 on the bottom. Okay. Now, that works for x going to infinity. For x going to minus infinity, I got to be a little more careful, because as I slid this in, right, if x was negative, this square root's a positive number. If x is a negative number, then 1 over x is negative, and this numerator is negative. But yet when I slid it inside like this, I'm saying it's positive again. So in that case, I would have had to throw a minus sign out in front to remember that it was negative when I started. Okay. Personally, I think it's easier to lose the minus sign with this method than it was up here. Right? Up here, I'm paying attention to what's the most important thing. The most important thing is the biggest power of x on the bottom, the biggest power of x on the top. That biggest power of x happened to be buried underneath the square root, and so taking it out, I'm just careful as I take it out, and I see that there may be something different happening for positive or negative x's. Okay. Notice down here, the stuff that gave us the stuff that mattered was the biggest power here on the top and the biggest power on the bottom. So there you go. No, let me draw a graph of this thing. So here's the graph. Notice there's a vertical asymptote at 9/7. But we're looking at what's happening as x is going to infinity and minus infinity. So as I keep sliding this way, it almost looked like maybe it was headed down to get close to the x-axis, but it doesn't. It's staying away from the x-axis here. If I zoom in, right? So there's 0.5. So yeah, we're at about 0.3. About 0.3. Do I have the right function in there? I should have 2/7 is what we said. What is 2/7? About 0.28 something. So it's a little bit less than 0.3 if I zoom in a little more. Oh, this is really dang close to 0.3. It should be getting close to 2/7. So over I go. Oh, the problem is I hadn't gone over far enough. It's going down. I've gotten a little bit below 0.3 now, and the further I go, the closer it's going to get to 2/7. And then I want to see what's happening on the negative side. So I'm zooming out a little bit here. Let's come back. Okay, there's the axis. Let's go over to the negative side and see now the horizontal asymptote is down here at negative something. So I'll move way over. Actually, I'll probably move faster by zooming out and then moving over. Oh, now we're really moving out here. So we got some really big negative numbers, and then we can zoom in and see how big that function really is. And this zoom is always goofy. I haven't figured out what the stable point is. There we go. So we're looking at negative 2.8-ish. So yeah, there's a function with two different horizontal asymptotes. One more thing to point out. One more thing to point out. Yes, it has horizontal asymptotes. And it crosses the horizontal asymptote. Notice the function right here, close to 0, all right? It's negative, it comes up really close to 0, and then it comes back down onto this from above. So somewhere there's a spot over here where it crosses the horizontal asymptote. You are allowed to cross horizontal asymptotes. It's vertical asymptotes that never get crossed.